You are lying perfectly still, and you have never moved faster in your life. Right now, in this quiet moment, you are falling through space at more than 1.3 million miles an hour. That is the title of the journey you clicked tonight, and it is the very image on your screen. A small, still world, and a single resting figure upon it, hurtling without a sound through the freezing dark. It is not a trick, and it is not an exaggeration. It is simply, strangely true. You feel completely motionless. You are racing through the cosmos faster than any rocket humanity has ever built. Both of those things are true at this very second, and the gentle space between them is the whole of what we are going to drift through together tonight. So tonight, we're going to explore exactly how that can be, how your body can rest in such perfect, silent stillness while it carries you through the void at a speed that defies all human scale, how you can lie here warm and heavy and at peace, while the chair beneath you, the bed beneath you, the whole of the floor and the house and the ground, all of it races through the dark at over 1 million miles an hour, and not one of your senses gives the slightest hint that anything is moving at all. Before we begin, let yourself settle. There is no hurry here, none at all. Find whatever position feels easiest, and let the small adjustments come. The shoulders dropping a little lower, the jaw loosening, the hands going soft. Let the weight of the whole day begin to loosen its grip on you, one finger at a time. There is nothing in this journey you need to follow closely. Nothing you need to hold on to. Nothing you need to remember in the morning. You can let your eyes close whenever they would like to. You can let the words blur and drift. Let the sound of this voice simply carry you through the cosmos, layer by gentle layer, while the world holds you exactly where you are. Here is the first strange and lovely thing worth knowing, the thing that lets us sleep through all of this. Your body has no sense for speed, none at all. We often imagine that we can feel ourselves moving, but what we actually feel is something quite different. We feel change. We feel the push of a car as it gathers speed, the soft tug as it slows, the lean of our body as it rounds a bend in the road. What we are sensing in all of those moments is acceleration, the change in our motion, the speeding up and the slowing down and the turning. We never sense the motion itself. And so, when a ride becomes perfectly smooth, when the speed holds steady and the path runs straight and true, that feeling of movement simply vanishes. The motion becomes completely invisible to us. We could be sitting perfectly still, or we could be flying faster than sound, and from the inside, with our eyes closed, the two would feel exactly, identically the same. More than 400 years ago, a man named Galileo Galilei understood this more deeply than anyone of his age, and he captured it in an image so gentle and so clear that we still reach for it today. He asked you to imagine a great sailing ship, a tall and heavy vessel, gliding smoothly across a calm and glassy sea. And then he asked you to picture yourself deep down inside that ship, in a cabin below the deck, with no windows, no porthole, no way at all to see the water sliding past outside. Now, Galileo asked, here is the question. If the sea is perfectly smooth and the ship moves steadily, holding one speed and one heading, is there any test you could perform, sealed inside that windowless cabin, to tell whether the ship is sailing swiftly forward or sitting perfectly still at anchor? And the answer, he realized, is no. There is nothing you could do. Drop a coin, and it falls straight down to the floor, exactly as it would in a ship tied to the dock. Pour water from a jug, and it pours the same. Watch a fish swimming in its bowl, and it swims no differently. Toss a ball gently into the air, and it comes straight back down into your hand. Every experiment gives the very same answer, whether the ship is racing across the open sea or resting still in the harbour. Motion, when it is steady and smooth and unbroken, hides itself completely from the people being carried along inside it. It leaves no trace that any sense can find. We are all of us passengers in Galileo's windowless ship. The earth is our great cabin. The smooth and glassy sea is the gentle, unwavering motion of the cosmos, a motion so steady that across our whole lives it never once jolts or shudders to give the secret away. This is the reason you can lie here in total peace while you travel, in a single hour, a distance greater than the span of an entire continent. There is no jolt to wake you. There is no wind to warn you. There is only the smooth and silent gliding, the same as stillness, indistinguishable from rest. And here is the second strange and beautiful truth, the one that makes the whole of it feel less like a machine and more like a kind of grace. None of this motion comes from engines. Nothing out there is burning. Nothing is roaring or pushing or straining to drive us forward. The earth is not powered through space the way a ship is rowed or driven through water. Instead, we are falling. Always falling, endlessly and gently falling, in the deepest and most graceful sense of that word. We fall around the sun, the way a stone whirled on the end of a string falls around your hand, forever curving inward, forever missing, never dropping. The sun, in its turn, falls around the distant heart of our galaxy, and the galaxy itself falls toward its great neighbors, drawn through the dark by the quiet, invisible shape of space itself. We will come to understand that shape slowly and softly as the night goes on, and there will be no rush in the understanding. For now, it is enough simply to know that gravity is not a hand reaching out of the dark to seize us. It is far gentler than that. It is more like a valley, a long, smooth slope in the landscape of space, and we are simply rolling along the easiest path that valley allows, the way a marble settles to the bottom of a bowl. We are not being pulled against our will. We are being carried, the way a leaf is carried by a slow stream, along the gentlest course there is. And we have been falling like this for an unimaginably long time. We have been falling since long before there were any eyes on this world to wonder about it. Long before the first small creature ever lifted its head toward the stars. The fall is older than language, older than fire, older than the first forests, older than the oceans themselves. It is older than life. We were already falling, quietly and perfectly, before the earth had cooled enough to hold a single drop of rain. Tonight, we are going to count the layers of that long fall, one by one, slowly, with nothing hurried and nothing skipped. We will begin with the ground directly beneath you, the soft turning of the whole planet as it spins, the slowest and the nearest of all our motions. Then we will lift away from it, gently, rising up into the wider dark. We will follow the earth as it sweeps in its great circle around the sun. We will follow the sun as it carries its entire family of worlds in a vast and patient loop around the heart of the galaxy. We will drift with our star through the thin and glowing clouds that float in the spaces between the stars. We will lean with the whole of the Milky Way toward a distant sister galaxy that has been falling toward us for longer than our kind has walked the earth. And then we will go further still, out past all of that, to the very edge of what we are able to measure, where entire vast cities of galaxies slide together like quiet streams running down into a single hidden valley. 7 layers of motion in all, 7 nested speeds, each one folded gently inside the next, each one grander and larger and slower than the one before it, and every single one of them carrying you right now in perfect and unbroken silence, while you do nothing at all but breathe. But there may be an eighth. At the very end of our journey tonight, far past the reach of any telescope's clear and certain sight, there waits a question that some of the most careful and patient minds in all of science are still turning over quietly in the dark. It is a faint hint, written into the light of the most distant objects we have ever found, that our entire visible universe might be drifting ever so slightly in a single direction, towards something, or perhaps away from something. We are not yet sure which, or whether it is truly there at all. It may turn out to be real, a true eighth current running beneath all the others, the deepest motion of them all. Or it may quietly dissolve into nothing as our instruments grow sharper and our eyes grow clearer in the years to come. And that, in its own way, is one of the gentlest gifts this kind of science can offer us. We are allowed tonight to simply rest inside the question, with no need at all to force an answer before we sleep. So take a slow breath in now, hold it softly for just a moment, and then let it go even slower than it came, letting your whole body grow a little heavier as the breath leaves you. There is nowhere you need to be tonight, and nothing you need to do. The earth has been carrying you faithfully through every one of these layers since the very moment you were born, holding you safe through all of it, and it will go on carrying you just as faithfully, long after you have drifted off to sleep. So let us begin our slow descent together, then down into the quiet, cascading motions of our cosmic home. We will start, as all of this gently does, with the ground beneath you and the soft and silent turning of the world. Before we lift away from the earth, it's worth pausing on a simple question, the kind that sounds almost childlike until you sit with it. If we are moving so fast, through so many layers of motion all at once, how is it that we can lie here and sleep through every bit of it? Why doesn't the universe feel like a wild carousel, flinging us in a dozen directions? The answer is one of the most quietly profound ideas in all of physics, and it arrived gently from the mind of a young man who once described the thought that led to it as the happiest of his life. His name was Albert Einstein, and the happy thought came to him, he later said, while he was sitting at his desk, idly imagining a person falling from a height. He realized something that no one before him had quite put into words. A person who is falling freely does not feel their own weight. As they fall, they feel weightless, light, unburdened. The pull of gravity, in the very act of obeying it completely, seems to vanish. That single image, a falling person who feels no weight at all, unlocked the deepest understanding of gravity we have ever had. To feel your way into it, imagine waking inside a small windowless room, somewhere far out in the dark. You drift in the middle of the room, weightless, your arms floating loose at your sides, nothing pressing on you anywhere. Now here is the question Einstein turned over. Are you resting in the deep quiet of empty space, drifting far from any star or world? Or are you in fact falling, this very moment, plunging freely towards some distant planet with nothing beneath you to break the fall? And the astonishing answer is that you cannot tell. There is no experiment you could perform, no measurement you could take inside that sealed room that would reveal the difference between floating in empty space and falling freely through it. To your body, and to every instrument you might carry, free fall and weightlessness are one and the same thing. Falling, when nothing interrupts it, feels exactly like perfect stillness. It feels like rest. You have very likely seen this with your own eyes, even if you never knew that was what you were watching. Think of the astronauts who live aboard the space station, drifting through their cabins, tumbling slowly, their hair floating around their faces. It is easy to assume they float because they have escaped gravity, because they are simply too far from the Earth for it to reach them. But that is not it at all. Up where they orbit, only a few hundred miles above the ground, the Earth's gravity is very nearly as strong as it is down here. They are not beyond its pull. They are falling. The space station and everyone inside it is in a state of constant, endless free fall, curving around the Earth so fast that it keeps missing the ground, falling forever in a great circle. And because they are all falling together, smoothly and steadily, they feel nothing. They float. They rest in their fall exactly as we do. That is the secret of our peaceful night. We are not being shoved or hauled in any direction our bodies can register. We are simply falling freely and smoothly through the gentle curves of space. And free fall, as Einstein showed us, feels like nothing at all. So let us soften that word, gravity, because the old picture of it is misleading, and the true picture is far more beautiful. We tend to imagine gravity as a kind of invisible rope, a force reaching out across empty space to seize hold of distant things and pull them in. But that is not how the universe works. Einstein gave us an image you can almost feel with your hands. Picture a large, soft sheet, stretched flat and held taut at its edges, like the surface of a trampoline. Now set a heavy bowling ball down in the very middle. The sheet sags. It curves downward into a deep, smooth bowl around the weight. Nothing is reaching out. Nothing is grasping. The ball has simply changed the shape of the surface around it, and now roll a small marble across that sheet, off to one side. Watch what it does. The marble feels no rope, no tug from the bowling ball. It simply follows the curve of the fabric, spiraling gently inward along the slope, drawn toward the heavy center, not by a force, but by the shape of the space it moves through. That is gravity. Mass tells space how to curve, and the curve of space tells everything else how to move. The Earth presses a great soft well into the fabric of space around it, and the moon rolls endlessly around the rim of that well. The sun carves a vast valley, and the planets trace the long, gentle slopes of it. And it is not only space that bends. Time itself curves too, slowing ever so slightly wherever gravity grows strong, so that a clock at the bottom of the well runs a hair slower than a clock high above it. That last part can sound like pure fancy, time itself running at different speeds, and yet we lean on it every single day without ever noticing. The satellites that carry the positioning signals to the phone in your pocket orbit high above the Earth, where gravity is a little weaker and time runs a tiny bit faster than it does down here on the ground. The difference is unimaginably small, a few millionths of a second each day, but it is real, and it matters. If the engineers did not constantly correct their clocks for the bending of time, the maps on our phones would drift off by several miles within a single day, and nothing would ever be where it said it was. Every quiet, ordinary moment of finding your way somewhere is built upon the gentle truth that time bends near the Earth. The strangeness is not far away in the cosmos. It is woven into the most everyday corners of our lives. The fabric of space and time can do more than bend too. It can ripple. When something truly enormous moves sharply out in the universe, two black holes spiraling together, say, it sends gentle waves rolling outward through the fabric itself, like the ripples that spread when a stone drops into a still pond. For a century these waves were only a prediction, far too faint to ever hope to catch. And then, in the year 2015, two exquisitely delicate instruments here on Earth felt one pass through. It had come from two black holes that had collided more than 1 billion years ago, unimaginably far away, and by the time the ripple reached us, it stretched and squeezed all of space by less than the width of a single atom. We felt it anyway. For the first time, humanity sensed the fabric of the universe quivering, and knew for certain that it was real. The space you are resting in tonight is not a fixed and empty stage. It is a living thing that bends and sags and trembles and quietly carries us along. We are not being held down tonight by a hand gripping our bodies. We are resting near the bottom of a smooth, deep valley in space and time itself, and there is no more peaceful place to be. But there is still a puzzle hiding here. If we feel no motion, then how, in all the long ages of human history, did anyone ever come to suspect that we were moving at all? To know that you are moving, you need something to measure yourself against. A still point, a fixed backdrop, standing on the spinning, orbiting Earth, with everything around us moving along with us. Where could such a backdrop possibly be found? It turns out that one exists, and it is everywhere, in every direction you could ever point. It is the oldest light in all the universe, and the story of how we found it is one of the loveliest accidents in the history of science. In the 1960s, two researchers at a laboratory in New Jersey, named Arno Penzias and Robert Wilson, were working with a large horn-shaped antenna, trying to measure faint radio signals from space. But they kept picking up a persistent, gentle hiss, a faint static that came from every direction at once and would not go away no matter what they did. They checked their equipment over and over. They even discovered that a pair of pigeons had been nesting inside the antenna, and they carefully cleaned out the birds and their droppings, thinking that might be the source of the noise. But the soft hiss remained, steady and even, coming from the whole sky at all hours. It was not a flaw in their machine. It was not the pigeons. It was the universe itself. That faint, even hiss was the afterglow of the Big Bang, the cooled and stretched out light left over from the first few 100,000 years of everything, a glow that fills all of space and has been quietly traveling since before the first stars were born. We call it the cosmic microwave background. It is astonishingly cold now, just a few degrees above the very coldest temperature there is, chilled by billions of years of the universe slowly stretching wider. And it is everywhere. It surrounds us like the still, calm surface of an ancient sea. In the days of old televisions, when you turned to an empty channel and saw that gentle snow of static dancing on the screen, a tiny part of that flicker was this very light, the breath of the early universe, faintly stirring in your living room. What makes that ancient glow so remarkable is how smooth it is. Look in any direction at all, and it shines at very nearly the same gentle temperature, the same in the north of the sky as in the south, matching from one side of the heavens to the other to within a tiny fraction of a degree. The early universe was almost perfectly even, almost perfectly calm, but not quite, and the not quite is everything. Woven into that smooth glow are the faintest ripples, patches a hair warmer and a hair cooler than their surroundings, differences so slight they took decades and a series of delicate space telescopes to map. Those tiny ripples were the seeds. Where the early universe was a touch denser, gravity slowly gathered more matter and more over billions of years, until those faint warm patches grew into the great clusters of galaxies, and the cooler patches thinned into the vast empty voids between them. Everything you have ever seen, every star and every galaxy, our own Milky Way included, grew from those gentle ripples in the oldest light. The still backdrop against which we measure our motion also holds, written faintly across it, the first blueprint of everything that would ever come to be. And here is why that ancient glow matters so much for our journey tonight, because it is so even, so still. It gives us, at last, the fixed backdrop we needed. By measuring how the light looks ever so slightly warmer in the direction we are heading, and cooler in the direction we are leaving behind, we can finally read off our true motion through the cosmos. The universe handed us a mirror, faint and cold and beautiful, in which our hidden speed becomes visible. We will return to that mirror near the very end of the night, when we reach for the grandest motion of all. For now, simply know that it is out there, all around us, holding perfectly still while we move. So let us begin to count. Let us start with the first layer, the slowest and the nearest, the one happening right beneath your resting body at this very moment. The Earth is spinning. It turns once each day, carrying us all the way around in a great silent circle, out of darkness into light and back into darkness again. And it does this quickly, far more quickly than our calm senses ever let on. If you were lying near the equator tonight, the ground beneath you would be sweeping eastward at around 1,037 miles an hour. That is faster than the speed of sound. The floor you are resting on, if you were near that warm middle band of the world, is racing through the night quicker than a fighter jet, and you feel nothing at all. The Earth even bulges out a little around its waist, swelling at the equator from all that swift turning, like the slow widening of a spun ball of dough. Further from the equator, up where most of the world's great cities sit, the ground still carries you eastward at many hundreds of miles an hour. Only if you stood exactly at the North or South Pole would you simply turn slowly in place, like the still center of a vast turning wheel. That spin shapes more of your world than you might guess, because the ground near the equator races eastward faster than the ground near the poles. Anything that travels a long way across the surface of the Earth gets gently nudged off a straight path, curving slowly as it goes. It is the reason the great storms of the world turn in their vast, slow spirals, rather than simply blowing in a straight line. The whole weather of the planet quietly wound up by the turning beneath it. The spin you cannot feel is sketching the shapes of the clouds far overhead, and stirring the oceans, and steering the winds, all while you rest beneath it, unaware. How could anyone ever prove such a thing, when every sense we have insists the ground is perfectly still beneath us? The proof came on a winter's day in Paris, in the year 1851, from a patient and ingenious man named Léon Foucault. Foucault hung a long wire, 67 meters of it, from the high domed ceiling of a grand Parisian building called the Panthéon. At the bottom of that wire he fixed a heavy bob of brass, a polished weight of nearly 30 kilograms. Then he drew it gently to one side and let it go. The great pendulum began to swing, slow and steady, back and forth, tracing a long line across the floor far below. And here is the wonder of it. A swinging pendulum, once set going, wants to keep swinging in the very same direction forever. It has no reason to turn aside. And yet, as the hours passed and the gathered crowd watched in hushed amazement, the line of its swing slowly rotated, drifting around the floor like the hand of an enormous, unhurried clock. But the pendulum was not turning. The floor was. The whole building, the whole city, the whole of France was wheeling slowly beneath that faithful swinging weight, carried around by the turning of the earth. For the first time, people could stand still and watch, with their own eyes, the rotation of their world. The effect even changed depending on where you stood upon the planet. At the poles, the floor would sweep a full circle beneath the pendulum in a single day. In Paris, It took a little over 30 hours for the swing to come all the way around, and at the equator, the pendulum would not turn at all. Foucault had taken the most hidden motion imaginable, the spin we can never feel, and made it visible to anyone with the patience to watch a heavy weight swing in a quiet hall. To this day, pendulums like his hang and turn in museums and great halls all over the world, each one quietly tracing the same slow truth. Today we no longer need a pendulum in a cathedral. We measure the Earth's turning with instruments called ring laser gyroscopes, devices so exquisitely sensitive they can sense the planet's rotation down to the smallest fractions of a second. With them we have learned that the spin is not perfectly steady. The length of a day wavers by the tiniest amounts, nudged by the shifting of winds and oceans and the slow stirring of the Earth's molten heart, so slightly that only the most delicate clocks can notice. But beneath all those small wobbles lies one long, gentle, unmistakable trend. The Earth's spin is very slowly winding down. Each century, the day grows longer by a little under 2/1000ths of a second, the faintest easing of the pace, caused by the soft and constant pull of the moon. As the moon circles us, its gravity raises the great tides in our oceans, and the slow drag of those tides acts like the gentlest brake upon our spin. And as the Earth slows, the moon, in the same patient exchange, drifts very gradually away from us, retreating by about 1.5 inches each year, slipping a little further into the dark as the ages pass. It is almost nothing, that slowing, a blink across 100 years, but stretch it back across the deep history of our planet, and it becomes something to marvel at as you drift off. When the Earth was very young, freshly formed and still cooling, a single day lasted only about 6 hours. The sun would rise and set 4 times in what we would now call one day, and the newborn world spun in a frantic, dizzy rush. We can even read the slowing in the fossils of ancient sea creatures. Certain corals, as they grew, laid down fine bands like the rings of a tree, a band for each day and a thicker pattern across each year. And in corals that lived some 400 million years ago, we can count more than 400 of those daily bands within a single year. Back then, the year held 400 days, because each day was shorter, only about 22 hours long. Across all the patient ages since, the moon has gently lengthened our days, smoothing our frantic young rhythm, slowing us down and down until it became the calm, steady, 24-hour turning that now carries us softly from one night into the next. So that is the first layer of our long fall. Not truly a fall yet, but a spin, the soft eastward turning of the ground beneath you, sweeping you faster than sound through the dark, so smoothly that a brass weight in Paris had to swing for hours just to coax the secret into the open. The very same gentle turning that, over billions of years, the moon has slowed into the rhythm, now rocking you toward sleep. And now, gently, we begin to lift away. We rise up off the spinning surface of the Earth and draw back, until the whole planet hangs before us, turning slowly in the black, wrapped in its thin shell of air. Because the Earth is not only spinning, it is also traveling, sweeping along an enormous curving road through space, falling endlessly around the sun. And the speed of that journey is something far greater than the spin we are leaving behind. So we have left the spinning surface behind, and now the whole Earth floats before us in the dark, a blue and white world turning quietly on its own. But it is not staying here. It is traveling, sweeping along a vast curved road through space, falling endlessly around the sun. And the speed of that journey would take your breath away, if a motion this smooth could ever be felt at all. The Earth travels around the Sun at roughly 66,600 miles an hour. Let that number settle softly for a moment, the way snow settles on a still night. We are not speaking of the speed of a jet, or even a rocket lifting off the launch pad. At nearly 30 kilometers every single second, the Earth moves about 30 times faster than a rifle bullet, leaving the barrel of a gun. And you are riding it, right now, wrapped warm in your blankets, perfectly at ease. You are flying around our star far faster than any bullet ever fired, and the ride is so smooth, so utterly without a tremor, that every sense you own swears you are lying completely still. This is Galileo's windowless ship again, only now the ship is the whole planet, and the sea it sails is the long curving valley the sun has pressed into the fabric of space. We feel none of it, because the motion never changes its gentle character. There is no lurch, no shudder, no wind against our faces. Just the soft and ceaseless falling that we have called home since before we were born. The road we travel is not a perfect circle, though it comes very close. It is a gentle ellipse, an almost circular oval, with the sun sitting a little off to one side rather than dead in the middle. And so, across the year, our distance from the sun very slowly breathes in and out. In the first days of January, the Earth swings to its closest approach, a little under 92 million miles from the sun. 6 months later, in the early days of July, it drifts out to its farthest point, around 94.5 million miles away. It is a small difference across such vast distances, only a few %, but it is real, a slow yearly tide in our nearness to the fire that warms us. And here is something tender that this reveals, a quiet correction to a thing many of us once believed as children. You might expect that summer comes when the Earth is closest to the sun, and winter when it is farthest away. It seems so reasonable, but it is not so. In fact, for those in the northern half of the world, the Earth is nearest the sun in the depths of January, in the cold heart of winter, and farthest from it during the warmth of July. The seasons do not come from our distance at all. They come from the gentle tilt of the Earth, leaning a little on its axis as it travels, so that through half the year the northern half tips toward the sun and bathes in long, warm days, and through the other half it tips away into the soft cold of winter. The same tilt, the same lean, simply turned the other way as we round the far side of our orbit. There is a quiet poetry in that, the year turning not because we move closer to the warmth or further from it, but because our world bows its head, first one way and then the other, as it circles. As the Earth swings around this ellipse, it does not even hold a steady pace. It speeds up a little as it sweeps in close to the sun in January, and eases off again as it drifts out to its distant point in July, like a sled gathering speed at the bottom of a gentle hill and slowing as it climbs the far side. 400 years ago, Johannes Kepler discovered the lovely rules hidden in this dance, 3 of them in all, and they are worth holding gently because they govern not only our world, but every world that circles a star. The first is the shape itself, that the planets travel not in perfect circles, as everyone had always assumed, but in those soft, slightly stretched ellipses. The second is the rule of the changing pace. Kepler found that the line joining a planet to the sun always sweeps out the same area of space in the same amount of time, whether the planet is near or far. Closer in, where that line is short, a world must travel faster to sweep the same area. Farther out, where the line is long, it may dawdle. It is a kind of cosmic fairness, a quiet balance kept across the whole orbit. And the third rule is the gentlest of all. The farther a planet lies from the sun, the slower it moves, and the longer its year, in a precise and faithful mathematical harmony that holds for every planet alike, as though the whole solar system were a single great instrument tuned to one quiet chord. And you can hear that chord in the planets themselves, each keeping its own stately time. Little Mercury, huddled close to the Sun, races around in only 88 days, hurtling along at over 100,000 miles an hour. Our own Earth takes its measured year, and far out in the cold and the dark, distant Neptune creeps along so slowly that a single one of its years lasts about 165 of ours. Neptune has not yet completed even one full orbit since the day it was discovered. Each world moves at exactly the pace its distance demands, the inner planets quick and bright, the outer ones slow and patient, all of them circling in the same direction, all of them tracing the same great harmony Kepler first heard in the numbers. For a long time, though, no one understood why the planets moved this way. Kepler had found the rules, the shapes, and the rhythms, but not the reason behind them. That reason came from an Englishman named Isaac Newton, and the story that has always been told, true or not, is a humble one. Newton, the tale goes, was sitting in a garden when he watched an apple fall from a tree, and he wondered, in that quiet moment, whether the very same pull that drew the apple gently down to the grass might reach all the way up to hold the moon in its orbit. It was an astonishing thought, that the homely tug which makes a teacup fall from a table and the grand force which swings the moon around the earth might be one and the same thing, a single law reaching from the smallest fall to the largest. And Newton showed, with patient mathematics, that it was true. One law of gravity reaching out between all things in the universe, between the apple and the earth, between the earth and the moon, between the sun and all its planets, was enough to explain every one of Kepler's beautiful rules. The ellipses, the changing pace, the harmony of the years, all of it flowed from that single gentle law. The same force that holds you softly in your bed tonight is the very one that steers the planets through the dark. And consider, while we drift here, how very far away that warming fire truly is. The sun lies about 93 million miles from us, so distant that its light, the fastest thing in all the universe, takes a little over 8 minutes to cross the gulf and reach your eyes. The sunlight falling on the world today set out from the sun more than 8 minutes before it arrived. If the sun were somehow to vanish in an instant, we would carry on in full daylight for 8 more minutes, never knowing, before the darkness reached us. We never see the sun as it is, only as it was 8 minutes ago. And that same light, racing onward past us, takes hours to reach the outer planets, more than 4 hours just to arrive at distant Neptune, out at the cold far edge of our sun's family. The solar system is mostly emptiness, vast and quiet and dark, with a handful of small worlds scattered through an ocean of space, and at the center, one bright fire holding nearly all of it. Indeed, the sun is so much larger than everything else that it holds within itself more than 99 parts in 100 of all the matter in the entire solar system. Every planet, every moon, every comet and asteroid and grain of dust, all of it together is barely a crumb beside the sun. We circle a fire that is almost the whole of our world. It is worth wondering softly why all the planets should circle in the same direction and lie so nearly in a single flat plane, like a set of rings spread out around the sun. And the answer reaches back to our very beginning. More than 4.5 billion years ago, before there was an Earth or a sun at all, there was only a great slow cloud of gas and dust drifting in the dark. Something stirred it, perhaps the shock wave of a dying star nearby, and the cloud began to collapse under its own gravity, falling inward. And as it fell, it began to spin, faster and faster, the way a skater pulls in their arms and quickens their turn. And as it spun, it flattened, the way a lump of dough spun in the air flattens into a disk. At the center, the densest part gathered and grew hot and finally kindled into the sun. And out in the surrounding disk, the leftover material slowly clumped together, grain by grain, into the planets. That is why they all circle the same way and lie in nearly the same plane, even now. They are tracing still the spin of the cloud that made them. Our whole orderly solar system is the gentle memory of one slow turning cloud, set spinning before the Earth was born and turning faithfully ever since. Sit for a moment with how far this all carries you while you rest. The Earth is just under 8,000 miles wide, and along its orbit it covers that entire width, the full breadth of the planet from one side to the other, in only about 7 minutes. And tonight, as you sleep, the journey simply continues without you, faithfully, without rest. Across a single night, across 8 hours of sleep, the Earth will carry you more than 500,000 miles along its path around the sun. More than 500,000 miles, while you do nothing at all but breathe and dream. That is more than twice the entire distance from the Earth to the moon. You will wake in the morning in the same bed, in the same quiet room, and yet you and your whole world will have traveled a road longer than 2 round trips to the moon, falling the whole way, and you will not have felt the faintest thing. It took us a very long time to understand our place in all this turning, and the story of how we came to see it is a gentle one, told across many lifetimes. Long ago, in ancient Greece, a thinker named Aristarchus of Samos dared to suggest that the sun, and not the Earth, sat at the center, and that our world moved around it. But the idea was far ahead of its time, and it faded, set aside and nearly forgotten. For well over 1,000 years, the wisest scholars placed the Earth at the unmoving center of everything, with the sun and moon and stars all wheeling obediently around us. That was the picture handed down from the ancient astronomer Ptolemy, and it held firm for age after age, because it matched what the eye plainly sees. The ground feels still. The heavens appear to turn. What could be more obvious? Then, in the year 1543, a careful Polish thinker named Nicholas Copernicus gently moved the sun back to the center and set the Earth in motion around it. He had held the idea quietly for years, and the book that laid it out is said to have reached his hands only as he lay dying. Soon after, a Danish astronomer named Tycho Brahe spent decades measuring the positions of the planets with extraordinary care, night after night, building the most precise records the world had ever seen. And it was from Tycho's patient mountain of observations that Johannes Kepler, poring over the wandering path of Mars, finally worked out those 3 beautiful laws of orbiting worlds. Around the same time, an Italian named Galileo turned one of the first telescopes up at the night sky and saw things that quietly shattered the old picture. He saw 4 little moons circling Jupiter, plainly going around something that was not the Earth. He saw Venus pass through phases, like our own moon, in a way that only made sense if it orbited the sun. The heavens, seen up close, told their own story. And at last, with Newton's single law of gravity, it all came together into one seamless understanding. Piece by patient piece, across the centuries, ordinary curious people redrew our entire place in the cosmos. And what they learned, in the end, is that we had never been the still center of anything. We had always been travelers, falling around our star, and simply had not known it. If you are finding some quiet comfort in drifting through these layers tonight, you might let yourself subscribe before you fade off, so that these slow journeys through the cosmos can keep finding their way back to you on the night still to come. There is nothing to do right now but rest. It is simply there whenever you would like it, waiting as patiently as starlight. And so we arrive at a gentle turning point in our journey. We have followed the soft spin of the Earth and the great curving fall of the Earth around the Sun. It would be easy now to imagine that the Sun, at least, sits perfectly still, that our star is the steady anchor, the fixed campfire around which our little family of worlds quietly circles in the dark. For most of human history, that is exactly what people believed. The Sun felt like the center, the one unmoving thing in a sky brimming with motion. It seemed only natural that everything should turn around it, and that it should turn around nothing at all. But the Sun is not still either, not even close. The campfire we have been circling is itself racing through the night, carried along on a journey so enormous that a single lap around it takes longer than the entire age of the dinosaurs. Our star, and everything bound to it, including this small world and you upon it, is sweeping in a colossal circle around the distant heart of our galaxy, drifting through a great dark forest of hundreds of billions of other suns. And the speed of that journey makes everything we have spoken of so far seem almost gentle by comparison. So let us rise once more. Let us draw back from the Sun and its circling planets until they shrink to a single warm point of light, one quiet ember among countless others, and let us watch the slow turning of the galaxy itself begin to reveal its shape around us in the dark. Here is where the scale of things begins to open up beneath us, slowly, like a floor quietly giving way, to reveal a cavern far vaster than the room you thought you stood in. We are leaving the Sun and its little family of planets behind now, and drifting out into the great turning structure of our home, the galaxy we call the Milky Way. Try to picture its shape softly, the way you might picture a familiar place with your eyes closed. The Milky Way is an enormous spinning disk of stars, a great flattened pinwheel turning slowly in the dark, perhaps 100,000 light years from edge to edge. It holds somewhere between 100 and 400 billion stars, far too many for any mind to truly hold, each one a sun, many of them with worlds of their own. From far above it would look like a luminous whirlpool, with a glowing golden bulge at its heart, and long, graceful arms of stars spiraling outward, wound loosely around the center like cream stirred slowly into coffee. And our own Sun is out in one of those arms, a quieter spur of stars, about halfway between the crowded core and the thin outer edge, some 26,000 light years from the center. We live in the calm suburbs of the galaxy, far from the bright and busy downtown, in a peaceful stretch where the stars are spread thin and the nights are deep and dark. It helps to know what those graceful spiral arms truly are, because they are gentler and stranger than they first appear. You might imagine the arms as fixed bands of stars, sweeping around forever like the rigid blades of a pinwheel, but they are more like slow rolling waves passing through the disk, regions where the stars and the gas bunch up a little closer together for a while, the way cars on a long highway pile into a slow patch and then thin out again further on. As our Sun drifts along its orbit, it passes through these arms and out the other side over many millions of years. And where the gas is gently squeezed inside an arm, new stars are kindled, lighting up in bright young clusters along the crest of the wave. So the arms glow not because they hold the same stars forever, but because they are always coaxing fresh ones into being. The whole disk is so enormous that light itself, which crosses from the sun to the earth in 8 minutes, would need something like 100,000 years to travel from one edge of our galaxy to the other. If you could ride a single beam of light across the Milky Way, the entire human story, from the first painted handprint on a cave wall to this very night, would unfold and fade away many times over before you ever reach the far side. And our sun is not resting out here. It is sweeping along an immense orbit around the galactic center, riding the great carousel of stars, carrying the Earth and every other planet faithfully along with it. The speed of this journey is hard to hold in the mind. We are traveling along that galactic path at around 514,000 miles an hour, 500,000 miles an hour, and then some, all of us together, the whole solar system gliding through the dark as a single quiet caravan. To feel just how fast that truly is, think of the swiftest thing human beings have ever built. It is a small spacecraft called the Parker Solar Probe, sent to dive close to the sun, and at the fastest moment of its closest dive, it reaches about 430,000 miles an hour, the greatest speed any machine made by human hands has ever achieved. We are rightly proud of it. And yet, the galaxy carries our entire solar system faster than that, naturally, effortlessly, without burning a single drop of fuel. The grandest feat of speed our species has ever engineered is slower than the gentle turning of the wheel we were already riding. We outrun our fastest invention simply by lying still in our beds. Now let your mind drift inward, all the way to the heart of the galaxy, to the place we are forever circling. There, at the very center, sits something we cannot see with ordinary eyes, hidden behind thick clouds of dust and the glare of countless crowded stars. For a long time, we could only wonder what lay at the core. Then astronomers began to watch a handful of stars near the very center, and what they saw was astonishing. Those stars were whipping around something, an invisible point in space, racing along tight looping orbits at thousands of miles a second, swinging around an unseen anchor as though tethered to it by an invisible cord. By watching them circle patiently for years, astronomers worked out what they were orbiting. It is a black hole, a supermassive black hole with the mass of about 4 million suns, all collapsed into a single dark point at the galaxy's heart. We call it Sagittarius A star. But do not let the word frighten you in the dark, because the truth of it is far gentler than its reputation. Our galaxy's black hole is not a roaring monster devouring everything around it. It is, for the most part, quiet, calm, sleeping, almost. It sits at the center and holds the inner galaxy in its grip, and the stars near it dance their swift orbits in peace, the way the planets circle our own sun. It is simply the still anchor at the middle of the carousel, the heavy weight at the bottom of the deepest well, and we trace our long, slow circle around it from a safe and enormous distance, 26,000 light-years away, untroubled, carried gently around once every long galactic age. For most of human history, the heart of the galaxy was something we could only wonder about, never truly see. But our patience has been quietly remarkable. For decades, astronomers followed that small handful of stars as they looped around the invisible center, watching them swing through their tight and rapid orbits year after year after year. And from the shape of those orbits they worked out, with great care, the mass of the unseen thing the stars were circling. It was a feat of such devotion that it earned its discoverers the highest honor in science. And then, only recently, we managed something that once seemed impossible. By linking great radio telescopes from all across the Earth into a single enormous eye, astronomers gathered enough faint light to capture an actual image of the shadow of our galaxy's black hole, a dark round silhouette ringed in a soft glow of warm light. After all these ages of circling it blindly, we have finally looked upon the very heart of the Milky Way and found it calm and round and strangely beautiful in the dark. And here is one of the strangest and most beautiful things we have learned about our galaxy, a quiet mystery that holds it all together. When astronomers measured how fast the stars in the outer parts of the galaxy were moving, they expected the distant ones to drift along slowly, the way the far planets in our solar system orbit the sun far more lazily than the near ones. But that is not what they found. The stars at the galaxy's edges were sweeping around just as quickly as the stars further in, far too quickly for the visible matter alone to hold them in their orbits. By all the rules we knew, those outer stars should have gone flying off into the void long ago, flung loose like mud from a spinning wheel. Something unseen was holding them in. An American astronomer named Vera Rubin spent years carefully measuring these motions, and her work helped reveal that the galaxy is wrapped in a vast, invisible cocoon of something we still cannot see, something that gives off no light at all, but whose gravity holds the whole spinning disk together. We call it dark matter, and there appears to be far more of it than all the stars and gas and planets combined. So as you ride your great orbit around the galaxy tonight, know that you are held in your path, not only by the stars you could see on a clear night, but by a quiet, invisible presence woven all through the galaxy, unseen, unfelt, and yet cradling everything in its gentle grip. This galactic orbit is so vast that a single trip around takes a span of time almost beyond feeling. Astronomers call it a galactic year, the time for the sun to complete one full circle of the Milky Way, and it lasts somewhere close to 230 million years, 230 million years for a single lap. The sun has been shining for about 4.5 billion years, which means that in its entire long life, our star has made the journey around the galaxy only about 20 times, 20 laps in all of its history, and we are not even part way through the present one. The last time the sun was in roughly the place it occupies now, the very first dinosaurs were just beginning to walk the young Earth. Everything that has happened since, the whole long rise and reign and fall of those great creatures, the slow arrival of the mammals, the dawn of our own kind, every empire and every song and every life ever lived, the entire story of humanity from its very first morning, has all unfolded within a small fraction of a single turn of the galactic wheel. We have not been here even a heartbeat of galactic time, and the wheel turns on, carrying us, utterly unhurried. The path is not a flat and simple circle either. As the solar system glides along its great orbit, it also gently bobs up and down, rising a little above the thin central plane of the galaxy, and then sinking softly back below it, like a horse on a carousel that floats up and down as it goes around. This slow vertical rise and fall takes tens of millions of years to complete just once. A long, patient breathing motion, layered over our circular ride. As we drift up and down through the galaxy's disk, we pass through regions where the cosmic gas and dust grow a little thicker, and then thinner again, a slow rhythm written into the deep history of our world. Some have gently wondered whether that long bobbing might leave faint traces in the ancient story of life on Earth. It remains an open and uncertain idea, the kind of soft, maybe, that careful science holds loosely in an open hand, never gripping it too tightly. But the bobbing itself is real, a quiet up and down sway, riding atop our great circular journey, and you are riding that too, this very night. Now let us come back in gently, from the scale of the whole galaxy to the space immediately around our Sun, because there is another layer of motion here, closer and more intimate. The Sun is not only orbiting the galaxy, it is also drifting through its own local neighborhood, moving relative to the thin wisps of gas that happen to surround us right now. At this particular moment in cosmic history, we are passing through a tenuous little cloud of interstellar gas that astronomers have given a wonderfully soft name. They call it the Local Fluff, more formally, the Local Interstellar Cloud, and the Sun is drifting through it at around 50,000 miles an hour. It would be easy to imagine the space between the stars as a perfect, flawless nothing. But it is not quite empty. It is filled, ever so thinly, with the faintest haze of gas, just a scattering of atoms drifting in the dark, the thin and patient breath of the galaxy. Our little cloud is only a wisp, and we entered it sometime in the last several thousand years, and will likely drift out the other side in some tens of thousands more, on into the next thin cloud beyond. And stranger still, this whole region sits inside a much larger near emptiness, a great cavity in the gas called the local bubble, blown out long ago by the deaths of ancient massive stars, their explosions clearing a vast hollow in space hundreds of light years across, within which our Sun now quietly drifts. We live, it turns out, in a calm clearing in the galactic forest, a soft hollow swept clean by old fires that burned out long before we arrived. And the Sun's own family reaches far, far further than the planets alone, long past Neptune, past even the small icy worlds that drift beyond it. There is thought to lie a vast and ghostly shell, wrapped all the way around the solar system, a great spherical cloud of countless frozen comets resting in the deep cold. We call it the Oort cloud, and it is so unimaginably large that it may stretch a good part of the way to the nearest other star. Now and then, after drifting undisturbed for millions of years, one of those distant frozen travelers is gently nudged loose and begins the long fall inward toward the Sun. As it nears the warmth, it awakens, growing a glowing tail of gas and dust, becoming a comet that crosses our skies for a few quiet nights before slipping away once more into the dark for thousands of years. That faint and distant shell of sleeping comets is the true outermost edge of the Sun's domain, the last soft boundary of home before the space between the stars truly begins. And as our Sun moves through this thin gas, it does not travel naked and unprotected. The Sun pours out a constant wind of particles in every direction, a steady stream flowing outward past all the planets, and this solar wind inflates a vast protective bubble around our entire solar system. We call that bubble the heliosphere. It is our cocoon, the great soft shell that wraps around all of us and shields us from much of the harsher radiation drifting between the stars. You are, right now, nestled deep inside it, safe in the warm and sheltered heart of it. For a long time, scientists pictured the leading edge of this bubble crashing violently into the gas ahead of it, throwing up a shockwave like the sonic boom of a jet tearing through the sky. They called it a bow shock, and for decades it lived in every drawing of the solar system's edge. But then a small NASA spacecraft named IBEX, the Interstellar Boundary Explorer, looked carefully out toward that boundary, and it gently overturned the old picture. The Sun, it turns out, is drifting too slowly through the local fluff to slam a shockwave ahead of itself. It moves at only about 52,000 miles an hour through that thin gas, just a touch too gentle to break it. And so, instead of a violent shock, our bubble raises only a soft swell at its leading edge, a bow wave like the quiet curl of water that rises ahead of a slow boat, gliding across a still and glassy lake. There is no crash out there at the edge of everything, just a smooth, gentle parting of the interstellar sea as we drift through it. Even the very prow of our great protective bubble, the outermost edge of home, turns out to be calmer than we ever feared. We know the shape of that distant boundary not only from ibex, which maps the faint atoms streaming in from the gas beyond, but from two of the most beloved travelers our species has ever sent into the dark. The Voyager spacecraft. Launched in the 1970s, these two small craft flew gracefully past the outer planets, sending home the first close portraits of Jupiter and Saturn and their moons. And then they simply kept going, out and out, across the long, dark emptiness. And in August of 2012, Voyager 1 did something no human creation had ever done before. It crossed the very edge of the heliosphere, the outermost skin of the sun's protective bubble, and slipped out into true interstellar space. It happened at a distance of about 122 times the span from the Earth to the Sun, so far away that out there the Sun is no longer a warming fire, but just one more bright star among the many. A few years later, Voyager 2 crossed that same threshold on the other side. And remarkably, both little craft are still out there, still whispering faint signals home across the void, signals so weak and from so far away that they now take nearly a full day, traveling at the speed of light, just to reach us. Each Voyager carries something with it too, a small golden record fixed to its side, etched with the sounds and music and greetings of the Earth, a quiet message from our world to whatever might one day find it drifting in the dark. Two small bottles cast into the cosmic ocean, carrying the gentle hello of everyone who has ever lived. They will outlast us all, long after this night, long after our own lifetimes. They will still be sailing outward through the layers we are mapping tonight, carrying our soft voices ever deeper into the quiet. So picture it all now, as we hold this layer in mind and let it settle. The sun and all its planets, our whole solar system, sealed inside a soft glowing bubble, raising a gentle wave at its leading edge as it drifts through a thin cloud of starlit gas, within a great clearing swept clean by ancient fires. And that whole bubble, with us cradled deep inside it, is itself being carried along on the vast galactic carousel, sweeping around the distant black hole at 500,000 miles an hour, held in its orbit by an unseen cocoon of dark matter, bobbing softly up and down through the disk as it goes. We are passengers within passengers, motion nested gently inside motion, every single layer smooth and silent and safe. And still we have not reached the end of our rising. For the galaxy itself, this whole vast pinwheel of hundreds of billions of stars, is also falling. It is being drawn gently and surely toward another great galaxy out there in the dark, the grandest neighbor in all our sky. And that slow fall has been underway for far longer than there have been human eyes to look up and notice it. Lift your gaze now, in your mind's eye, to the darkest and clearest night sky you have ever stood beneath. Far from any city, where the stars crowd thick and bright, and the band of the Milky Way arches overhead like spilled milk. If you knew exactly where to look, in the right season of the year, you could find a faint and ghostly smudge of light, no brighter than a breath of fog left on a cold window. It is the kind of thing you could walk past on 1,000 clear nights and never once notice. But that little smudge is the Andromeda Galaxy. It is the most distant object the unaided human eye can see, a whole separate island of around 1 trillion stars, hanging 2.5 million light-years away. and it is falling toward us. You can find it for yourself on the right kind of night, if you ever care to try. In the autumn months, when the great square of the constellation Pegasus rides high overhead, and the bright zigzag of Cassiopeia points the way, like an arrow scratched into the stars, that faint smudge waits quietly between them, ready for anyone patient enough to look. And here is the detail that surprises people most. Although it shows up as only a tiny blur to the naked eye, the full sweep of Andromeda, if our eyes were sensitive enough to gather all of its faint and far-flung light, would stretch across the sky several times wider than the full moon. We see only the bright little heart of it. The rest, the great spiral arms reaching out into the dark, spread silently across a patch of sky far larger than it appears, simply too dim for our eyes to catch. The grandest thing you can see with the naked eye is also, for the most part, gently hidden from it. Andromeda and our own Milky Way are the two great galaxies of our little corner of the cosmos, the twin giants of our local family, and across the immense gulf between them, they are drawn together by gravity, drifting closer at a speed of around 246,000 miles an hour. This is the fifth layer of our motion tonight. Not a spin, not an orbit, but a slow and stately fall toward another island of stars, a fall that has been underway since long, long before our species first opened its eyes. And these two great spirals do not travel alone through the dark. They lead a whole quiet entourage, gathered around them, bound together by gravity into a single family that we call the local group. Drift more than 50 galaxies in all, though nearly every one of them is small, a faint dwarf galaxy, a little gathering of stars that orbits the two giants the way moths circle a pair of distant lanterns. The Milky Way and Andromeda are the two great anchors of this family, and a third spiral, smaller than either, called the Triangulum Galaxy, drifts nearby like a junior sibling. All the rest are modest companions, some of them so dim that we have only found them in recent years, still quietly turning up in careful surveys of the sky. It is a small and close-knit neighborhood, in the grand scheme of things, just a few million light-years across, and it is the whole of the company our galaxy can call its own. Everything beyond it lies much, much further away, across far greater gulfs of empty space. To feel the wonder of this, it helps to remember how recently we even understood what Andromeda is. For most of human history, that faint smudge was just one more fuzzy patch in the sky, lumped in with the comets and the clouds of gas, called simply a nebula. No one knew what it truly was, and only a little over 100 years ago, astronomers fell into a great and genuine disagreement about it, a debate that came to be remembered by name. On one side stood those who believed these spiral smudges were small clouds of gas within our own Milky Way, which they took to be the entire universe. On the other stood those who suspected something far grander, that each smudge might be a separate galaxy, a whole other island of countless stars, unthinkably far away. No one could prove it either way. The scale of everything hung in the balance, waiting. The answer came in the 1920s from an astronomer named Edwin Hubble, working with one of the great telescopes of his day. Hubble managed to pick out individual stars within the Andromeda smudge, and among them a special kind of star that brightens and dims in a steady, faithful rhythm. Years earlier, a quietly brilliant woman named Henrietta Leavitt had discovered something beautiful about these pulsing stars. The slower they blink, the brighter they truly are, in a precise and dependable way, and that meant they could serve as a kind of measuring stick across the dark. By watching how slowly an Andromeda star pulsed, you could know how bright it truly was, and by comparing that to how faint it appeared from Earth, you could work out just how staggeringly far away it must be. When Hubble did the arithmetic, the answer was almost beyond belief. Andromeda lay far, far outside our own galaxy. It was a separate universe of stars unto itself. In a single stroke, the cosmos became unimaginably larger than anyone had dared to think, and our Milky Way shrank from being everything to being merely one island among countless others. We learned, in that moment, just how small and how cradled we truly are. But the news that Andromeda was approaching us had come even earlier, and more quietly, more than a decade before we knew it was a galaxy at all. In 1912, at the Lowell Observatory, perched high in the dry, clear air of Flagstaff, Arizona, an astronomer named Vesto Slipher carefully spread out the light of the Andromeda spiral into its colors, the way a prism splits sunlight into a rainbow. Threaded through that spectrum are fine dark lines, a kind of fingerprint, and by watching whether those lines were nudged toward the red end or the blue, Slipher could tell whether the object was moving away from us or toward us. Nearly every other spiral he looked at was shifted toward the red, racing away into the deep. But Andromeda was different. Andromeda's light was shifted toward the blue. It was not receding. It was coming closer. It was falling toward us, even then. And Vesto Slipher was the first human being who ever knew it. Years before anyone understood that he had been measuring the approach of an entire other galaxy. Now, the word collision can sound frightening, especially in the dark, especially as you are trying to drift off toward sleep. So let us be gentle and honest about what such a meeting would truly mean, because the reality is far softer than the word ever suggests. Galaxies are not solid things that smash. They are mostly empty space, with their stars scattered through them like a small handful of grains thrown across an entire ocean. To feel the scale of that emptiness, imagine shrinking our sun all the way down to the size of a single small marble. On that scale, the very nearest other star would be another marble lying thousands of miles away, across whole continents and seas. That is how vast and how empty the spaces between the stars truly are, almost unimaginably so. So when astronomers speak of two galaxies merging, they do not mean stars crashing into one another. Across such oceans of emptiness, almost no two stars would ever actually touch. The two galaxies would simply glide through and around each other, like two slow clouds of smoke drifting together in still air, their stars sliding silently past one another in the dark. What would happen, gently, over hundreds of millions of years, is that the vast clouds of gas the galaxies carry would meet and press together, and in that soft compression, whole nurseries of new stars would be kindled, lighting up the merging galaxies with the glow of newborn suns. The sun itself, our own star, would most likely be swung gently out to some new orbit, carried to a different neighborhood of the combined galaxy, while the Earth turned beneath it, untroubled, as it always has. And in the end, after the long, slow dance had settled, the two great spirals would blend into a single rounder galaxy, an elliptical one, its arms unwound, its motion calmed. Some have already given that far future galaxy a tender name, blending Milky Way and Andromeda together. They call it Milkomeda. And if the two galaxies do, in their slow time, draw together, the spectacle of it would surpass anything in our skies today, unfolding across spans of time too vast for any single life to follow. For billions of years, Andromeda would swell from that faint little smudge into a great glowing spiral growing slowly larger and brighter across the night, until at last it spread its luminous arms over the whole of the sky. A second river of stars hanging overhead, soft and immense and silent. No creature would ever witness the whole of it, for it would take far longer than our entire history to play out, from beginning to end. But night by distant night, across ages beyond counting, the heavens themselves would slowly transform, two galaxies leaning into one another in the gentlest and grandest embrace the universe allows. It is a thing too slow to fear, and far too beautiful to forget. And here is something quietly wonderful, a piece of news fresh enough that the textbooks are only just beginning to catch up with it. For a long time, this collision was taught as a certainty, a fixed appointment in the calendar of the cosmos, set for some 4.5 billion years from now. And then, very recently, astronomers went back to the question with the sharpest measurements ever taken, drawing on years of patient observation from the Hubble Space Telescope and from the Gaia mission, which has charted the precise motions of more than 1 billion stars, when they carefully folded in the gentle gravitational tugs of the other galaxies in our neighborhood, smaller companions like the large Magellanic Cloud and the Triangulum Galaxy. The certain future suddenly dissolved into something far more open. The odds of the Milky Way and Andromeda actually merging within the next 10 billion years turned out to be close to a coin flip, roughly even. And the chance of a true head-on collision came out at less than 1 in 50. One companion galaxy, they found, gently tugs us toward Andromeda and makes a merger a little more likely. Another tugs us off to the side, away from the meeting, and makes it less likely. And between those soft competing pulls, the future hangs genuinely undecided. So the fate of our galaxy, it turns out, is not carved in stone after all. The two great spirals may yet come together and settle into Milkomeda, or they may simply sweep gracefully past one another and drift onward, separate, each on its own long way through the dark for the rest of cosmic time. Both futures remain entirely possible tonight, and no one yet knows which one the universe will choose. There is a strange and gentle comfort in that, I think. Even the grandest motions, even the destinies of entire galaxies, are still being quietly decided, still uncertain, still softly in play. We do not have to know how the story ends in order to rest peacefully inside it tonight. If you have drifted with us this far into the dark, and you would like more nights like this one, a quiet tap to subscribe is enough to keep these slow journeys finding their way back to you. There is no need to stir, no need to do anything at all. It will keep, just like everything else out here in the patient dark, until you are good and ready. There is one last thing worth holding softly about Andromeda before we travel further, and it is the most beautiful thing of all. That faint smudge of light in the night sky, the one your eye can only just barely catch, is not showing you Andromeda as it is now. It is showing you Andromeda as it was. Light is swift, the swiftest thing there is, but the distances out here are so enormous that even light needs time, vast amounts of time to cross them. The light striking your eyes tonight left that galaxy around 2.5 million years ago, and it has been crossing the empty dark ever since, traveling all that long while just to reach you in this moment. 2.5 million years ago, on this small world, our distant ancestors were only beginning to shape the very first simple tools from stone. They had not yet learned to speak as we speak now. They had not yet tamed fire to their will, had not built a single wall or planted a single seed, had not dreamed even the faintest outline of the world we now take for granted. And across all those countless years, while our entire human story slowly unfolded, from those first chipped stones all the way to this very night, that ancient light was already on its way to you. It set out before there were human beings at all, and it arrives only now, tonight, to land softly on your eye. The two galaxies were already falling toward one another then, silently, patiently, bound together across the dark by the soft and unbreakable pull of gravity, long before there was anyone here to give either of them a name. You are looking at the deep past. Every single time you look up at the night sky, every star, every distant smudge of light is a kind of message sent long ago and only now arriving, a glimpse of how things were rather than how they are. And the deep past, it turns out, has been quietly falling toward you all along, drawing nearer through all the ages, while you did nothing but live your small and precious life beneath it. Now we go further still. We leave behind even our two great galaxies, Andromeda and the Milky Way both, and we pull back to a scale so vast that the entire Milky Way, all 100,000 light years of it, becomes a single faint point of light among thousands of others. Because both of our galaxies, along with dozens of smaller companions that travel with them, are all bound together into one great family. And that whole family, all of it at once, is falling together towards something so distant and so enormous that we cannot even see it directly. This is the layer where the title of our journey finally comes true. The full 1.3 million miles an hour. The number that has been waiting patiently for us since the very first words tonight. Our Milky Way and the great Andromeda Galaxy, along with around 50 smaller galaxies that travel in their company, all belong to a single bound family that astronomers call the Local Group. And this whole family, all of it together, is racing through space as one, falling in a single coordinated direction at a staggering 630 kilometers every second. That is the 1.3 million miles an hour we began with. Not the Earth alone, not the Sun alone, not even the galaxy alone, but our entire neighborhood of galaxies, all leaning the same way, all streaming together through the cosmos at more than 1 million miles an hour, drawn towards something far off in the dark. You might wonder how we could ever measure such a thing. Against what could we possibly clock the speed of our entire galaxy and all its companions? And the answer brings us back to that ancient light we spoke of long ago, the faint afterglow of the Big Bang, the cosmic microwave background that fills all of space and holds so beautifully still. Because we are moving through that ancient light, it does not look quite the same in every direction. In the direction we are heading, it appears very slightly warmer, the faint glow nudged a touch toward the blue, the way a sound seems higher in pitch as it rushes toward you. And in the direction we are leaving behind, it looks ever so slightly cooler. It is the gentlest imaginable signal, a difference of less than 1,000th of a degree across the whole sky, but it is unmistakable. By reading that soft, warm and cool pattern in the oldest light there is, we can measure our true motion against the universe itself. And what it tells us is that we are streaming at over 1 million miles an hour toward a particular patch of sky far down near the southern horizon. The ancient mirror shows us moving, and it shows us exactly which way. This great motion was first uncovered in the 1980s by a group of 7 astronomers who became known, half in jest, half in admiration, as the 7 Samurai. They had set out to measure the motions of many galaxies near our own, expecting to find them drifting this way and that, more or less at random, like leaves scattered on a still pond. Instead, they found something that quietly astonished them. The galaxies were not moving randomly at all. They were all flowing together, in the same direction, like a great slow river of galaxies all being carried toward a single distant point. Something out there, something enormous, was drawing in everything for hundreds of millions of light years all around. They could not see what it was, but they could feel its pull, written plainly in the motion of 1,000 galaxies. And so they gave it a name that has stayed with it ever since, a name with a touch of awe and a touch of dread, the Great Attractor. It is worth pausing on how anyone could possibly weigh the motion of a galaxy so impossibly far away. The method is a quiet and clever one. Because the whole universe is expanding, every distant galaxy is carried away from us at a speed that depends on how far off it lies, a steady and predictable drift. But when astronomers measure a galaxy's true motion and find it moving a little faster or a little slower than that steady expansion alone would explain, the leftover, that small extra nudge, is the galaxy's own private motion through space, its quiet drift toward whatever is pulling upon it. The seven samurai measured that leftover nudge for galaxy after galaxy, and found them all leaning the very same way. And years later, other astronomers gathered these private motions for many thousands of galaxies at once and wove them together into a single flowing map, charting the great currents of the cosmos much the way you might chart the currents of the ocean, by watching the slow drift of countless little boats upon it. What emerged from all those drifting points of light was a hidden landscape of valleys and ridges, written not in stone, but in the silent motions of the galaxies themselves. Here is the strange and almost haunting part of the story. We still cannot see it directly, even now. The Great Attractor lies in a particular patch of sky, roughly 250 million light-years away, that happens to sit right behind the dense and crowded disk of our own Milky Way. When we try to look in that direction, our view is blocked by the thick clouds of stars and dust in our galaxy's own body. A glowing curtain we cannot easily see past. Astronomers call that blocked region the zone of avoidance, because for so long the galaxies hidden behind it simply could not be found. It was a great blind spot in our map of the universe, a place we knew was crowded with something immense, and yet could not lay our eyes upon. Only by turning to other kinds of light, to radio waves and X-rays that can slip through the dust where ordinary light cannot, did we begin to glimpse what hides back there. We found a great crowd of galaxies, a massive cluster called the Norma Cluster, sitting near the very heart of the pool. And as we peered further, we found that the Great Attractor was not even the end of it. Beyond it, further still in the same direction, lies an even more colossal gathering of galaxies, one of the largest concentrations of matter known anywhere in our part of the universe. It is called the Shapley Supercluster, and it sits some 650 million light-years away, a vast metropolis of galaxies whose distant gravity may be part of what draws us onward. So the pull we feel is layered, like everything else tonight. A nearer attractor, and behind it a greater one still, and our whole local group sliding gently toward them both through the patient dark. But the story did not end even there. It only deepened and grew more beautiful. In the year 2014, an astronomer named Brent Tully and his colleagues did something quietly magnificent. They mapped the motions of many thousands of galaxies across our entire region of the universe, tracing the invisible flows, following the slow rivers of gravity, watching which way each galaxy drifted, until a vast hidden structure revealed itself out of the data, like a shape emerging from fog. They found that our galaxy, and the Great Attractor, and the Norma Cluster, and 100,000 other galaxies all belong to a single enormous formation, a supercluster so large the mind can scarcely hold it, stretching across some 500 million light-years, They gave it a Hawaiian name, one that means immeasurable heaven. They called it Laniakea. And there is a lovely way to picture what Laniakea is, one that asks nothing more of you than to imagine a landscape after rain. Picture a great range of mountains and valleys. Every drop of rain that falls upon it does not stay where it lands. It trickles downhill, gathering into rivulets, then into streams, then into rivers, all of them flowing along the valleys, all of them slowly draining toward the lowest point, the basin at the bottom of the whole landscape. A watershed, we call it, the entire region whose waters all flow toward the same low place. Laniakea is shaped like that, but written in galaxies instead of water. We are not so much being yanked toward the great attractor as we are gently sliding down a vast gravitational slope, following the long contours of our supercluster, drifting along the valley floor toward the low basin at its heart. 100,000 galaxies, all flowing like quiet streams of light down the gentle slopes of an immeasurable heaven. And we are one of those streams. You are riding a single tiny droplet of starlight as it slides down the longest, slowest, most enormous river in all of existence, and you cannot feel the current at all. It is almost impossible to truly feel how large Laniakea is. It stretches across some 500 million light years and gathers within it the light of 100,000 galaxies. To bring it down to any human scale, imagine the entire Milky Way, all 100,000 light years of it, shrunk down to a single grain of sand. On that scale, Laniakea would still be a sprawling thing the size of a great cathedral, and our whole galaxy just one grain among 100,000 others, scattered through its vast and quiet halls. And we do not even rest near the center of it. We live out toward the edge, on one of the gentle outer slopes, sliding slowly inward along with everything else toward the deep basin at its heart. We are a single grain of sand on the rim of a cathedral, drifting imperceptibly toward the floor, on a journey that will not finish for billions of years. This, it turns out, is the deep shape of the whole universe. The galaxies are not scattered evenly through space like grains of sand thrown at random. They are gathered into a great cosmic web, strung along immense glowing filaments and vast sheets, like droplets of dew strung along the threads of an enormous spider's web, or like the soft walls of a great cosmic foam. Between the threads lie tremendous empty voids, bubbles of near-nothingness, hundreds of millions of light years across, where almost no galaxies are found at all. And where the threads of the web cross and gather, the galaxies pile thick and bright into clusters and superclusters. Laniakea is one such gathering place, one rich knot in the cosmic web, and we live out near its quiet edge, sliding slowly inward toward the denser heart. These great voids are emptier and stranger than almost anything the mind can hold. Some of them stretch for hundreds of millions of light years, and within them you could travel for ages and see scarcely a single galaxy, only the long dark all around and the faint, distant glow of the filaments far across the emptiness. The cosmic web is the largest pattern that exists anywhere, the grandest structure in all of creation, and yet it grew from the smallest of beginnings. Remember those faint ripples in the ancient light, the tiny warm and cool patches woven through the afterglow of the Big Bang. Across billions of years, gravity took those gentle differences and slowly deepened them, gathering more matter into the denser spots and quietly emptying out the thinner ones, drawing the bright threads ever tighter and the dark voids ever wider, until the soft, early ripples had swelled into this vast and glowing web. The shape we drift through tonight was first sketched, ever so faintly, in the very first light of the universe, and has been patiently sculpted by gravity in all the ages since. We are sliding gently through a pattern older than the stars themselves. And then, just a few years after Laniakea was mapped, in 2017, came a final discovery that completes the picture in the most elegant way imaginable. A team, led by the astronomer Yehuda Hoffman, found that we are not only being pulled forward, we are also being pushed from behind. Behind us, on the opposite side of the sky from the great attractor, there lies an enormous emptiness, one of those great cosmic voids, a vast region with far fewer galaxies than normal. An empty space, in its own quiet way, pushes. Where there is less matter behind you, there is less gravity tugging you backward, and so you drift away from the emptiness just as surely as you fall toward the fullness ahead. They named this great void behind us the dipole repeller. So our motion through the cosmos is shaped by both at once, in perfect gentle balance. We are pulled forward by the dense and crowded regions ahead, and pressed softly onward by the great emptiness behind. Drawn and nudged, pulled and pushed, sliding down the long valley of Laniakea at more than 1,000,000 miles an hour, carried by gravity reaching toward us from one side and falling away from us on the other. Sit with that for a moment, here in the quiet of your room. Everything you have ever known, every person who has ever lived, every face you have ever loved, every ocean and mountain and city and song, the whole of human history from its first morning to this very night, all of it riding on a single small world, and that world circling one ordinary star, and that star sealed in its small bubble, drifting in one spiral arm, in one galaxy, in one local family of galaxies, all of it streaming together down an invisible slope toward a hidden basin we are only just beginning to map. And it is happening right now, in this very breath, while you lie here perfectly still, perfectly safe, perfectly at rest. You are part of the single largest motion we have ever measured anywhere in the universe, and you do not have to lift a finger to take part in it. The current carries you. It always has. It carried you before you were born, and it will carry you long after you have drifted off to sleep tonight. There is something almost tender in being so small and so completely carried. You are not asked to steer or to hold on, or to understand it all, or to keep any of it from slipping away. You are simply a passenger on the gentlest journey imaginable, one that began billions of years before you arrived and will continue billions of years after you are gone. The galaxies flow, the superclusters slide. The great web of light drifts slowly inward upon itself, and you are woven into all of it, held in the flow, asked for nothing but to rest. And we have very nearly reached the end of what we are able to measure. 6 layers of motion, now counted and named, each one grander than the last. The spin of the Earth, the fall around the Sun, the great carousel of the galaxy, the drift through the Local Fluff, the long fall toward Andromeda, and now the streaming of our whole local group down the slopes of Laniakea at 1.3 million miles an hour. But the universe, it seems, may have one more layer still, one we are only beginning to glimpse, written faintly in the light of the most distant things we have ever found, out at the very edge of what our instruments can reach. And it is the strangest and the most uncertain, and in its own quiet way the most wondrous of them all. So far, every layer we have counted tonight has been the motion of something through space. The Earth turning, the Earth falling around the Sun riding the galactic carousel, the local group sliding down the long slopes of Laniakea. But the 7th layer is different in kind, and stranger to feel, because the 7th motion is not anything moving through space at all. It is the motion of space itself. The universe is expanding, not rushing outward into some empty room that was waiting to be filled, and not flying apart from some central spot where it all began, but swelling gently from within, everywhere at once. Space itself is quietly stretching, growing, and as it stretches, it carries the distant galaxies apart from one another, the way marks drawn on the skin of a balloon drift apart as the balloon is slowly blown up. There is a homely little image that captures it perfectly, and it smells of a warm kitchen. Picture a lump of dough studded all through with raisins, set in the oven to bake. As it warms, the dough rises and swells, and every raisin slowly drifts away from every other raisin. Not because the raisins are crawling through the dough under their own power, but because the dough between them is growing. Now imagine you are one of those raisins. You would look out and see all the other raisins moving away from you, the nearer ones drifting off slowly, the farther ones receding faster still, and you might well conclude that you sat at the very center of it all. But every raisin sees exactly the same thing. There is no center, there is no edge. There is only the gentle universal swelling, the same in every direction, for everyone, everywhere. That is our universe. Every distant galaxy drifts away from every other, and from us, carried apart, on the quiet rising of space itself. We learned this less than 100 years ago, and it came from two minds in particular. A quiet Belgian priest and scientist named Georges Lemaitre worked out, from the equations, that the universe ought to be expanding, and that if you ran the expansion backward, it must have begun from a single, hot, dense beginning, an idea that would later be called the Big Bang. And an astronomer named Edwin Hubble, peering at distant galaxies, found the proof written in their light. The light from those far galaxies was stretched, shifted toward the red end of the spectrum, the way the dough stretches the space between the raisins. And the farther away a galaxy lay, the more its light was stretched, the faster it was receding. The galaxies were not fleeing from us in particular. The space between all of them was simply, gently growing. We had thought we lived in a fixed and eternal cosmos, an unchanging stage. We learned instead that we live in something alive, something that has been growing quietly since before the first star. It is worth dwelling for a moment on that stretching of the light, because it is one of the gentlest ideas in all of science. When light sets out from a distant galaxy and travels toward us across millions or billions of years, the space it is crossing keeps growing the whole while it travels. And as that space stretches, the light stretches along with it, its waves drawn out longer and longer, sliding slowly down toward the red end of the spectrum. We call it redshift, and the more space a beam of light has crossed, the more stretched and reddened it arrives. So the color of ancient light becomes a kind of clock, quietly telling us how far it has come and how long the universe has been growing beneath it. And this same gentle stretching leads to something that can softly astonish you. Although the universe is somewhere near 14 billion years old, the farthest things we can see are not merely 14 billion light years away, because space kept expanding while their light was traveling toward us. Those distant sources have been carried much further off in the meantime, so that the whole stretch of the universe we can observe is now something like 90 billion light years across. The visible universe is far larger than its age alone would ever suggest, simply because the ground beneath the light kept growing while the light made its long way home. For a long while after that, everyone assumed the expansion must be slowing down. Gravity, after all, pulls everything together, and surely across the long ages, it would be gradually putting the brakes on the cosmic stretching, easing it toward a stop, perhaps one day even drawing everything back inward again. But when astronomers finally measured it carefully, in the closing years of the last century, by watching the light of distant exploding stars far across the universe, they found the very opposite of what they expected. And it remains to this day one of the deepest mysteries in all of science. The expansion is not slowing down. It is speeding up. Something is pushing the universe apart faster and faster, gently but relentlessly. And because we genuinely do not know what that something is, we have given it a placeholder name that honestly admits our ignorance. We call it dark energy. It appears to make up most of the universe, around 2/3 of everything there is, more than all the stars and all the galaxies and all the dark matter combined. And yet, we cannot say what it truly is. It is the largest thing in existence, and very nearly the least understood. That discovery, that the expansion is speeding up rather than slowing, did not arrive gently. It came as a genuine shock, and from an unlikely direction. In the closing years of the 1990s, two rival teams of astronomers were quietly racing each other to measure how fast the cosmic expansion was easing off, each of them watching for the faint light of a particular kind of exploding star, far across the universe, to serve as a distant milepost. Both teams fully expected to find the expansion slowing, gently being reined in by gravity, as everyone assumed it must be. Instead, both teams, working entirely separately, arrived at the very same bewildering answer. The distant explosions were dimmer, and so further away, than any slowing universe could account for. The expansion was not breaking at all. It was speeding up. The two teams checked and rechecked, half disbelieving their own findings, and then announced, together, the same astonishing thing. It was one of those rare moments when the universe firmly refuses the story we expected of it, and hands us a stranger one instead. And we are still, all these years later, gently trying to understand what it was telling us. The mystery is still unfolding now, in our own moment. In just the last few years, a great instrument called DESI, the Dark Energy Spectroscopic Instrument, has been mapping tens of millions of galaxies across the sky, stitching together the largest three-dimensional map of the universe ever made, all in order to study this dark energy more closely than ever before. And its early findings have raised a gentle, tantalizing possibility. The hints suggest that dark energy might not be a fixed, unchanging constant after all, but something that very slowly shifts and evolves across the long ages of cosmic time. It is far too soon to be certain. These are early results, still being weighed and tested and argued over by careful people who know how easily the universe can fool us. But it is a quiet reminder that even now, in this very year, the cosmos is still handing us new questions faster than we can answer the old ones, and that there are people awake tonight, just as you are, turning these puzzles over gently in the dark. There is a soft and distant consequence to this accelerating expansion, and though it sounds lonely at first, there is a strange peace in it once you let it settle. Because space is stretching faster and faster, the most distant galaxies are slipping away from us more and more quickly, and across unimaginable spans of time, billions upon billions of years from now, they will recede so fast that their light will no longer be able to reach us at all. One by gentle one, over ages far longer than the universe has yet lived, the faraway galaxies will fade quietly from the reach of any telescope, until the deep sky grows simpler and emptier than it is tonight. But this is not a thing to fear, and it is not a thing for any of us, or our children, or their distant children's children, to ever witness. It lies further ahead than the mind can hold, and there is something tender in knowing that we happen to live in the bright early morning of the cosmos, when the sky is still full, when the light of countless distant galaxies still reaches us, when there is still so much to see. We arrived in time for the view. Now, you might feel a faint flicker of unease at all this stretching. If space itself is growing, pulling everything apart, then what about you? What about your room, your bed, your own quiet body lying here? And the answer is one of the most reassuring facts in all of cosmology, so let it settle over you like a warm blanket pulled up to the chin. You are not being stretched. Neither is your room, nor the earth beneath it, nor the sun, nor even our entire galaxy. Wherever gravity is strong enough to hold things together, and on these small and local scales, it is far, far more than strong enough. It simply overrules the gentle stretching of space. Galaxies bound into families stay bound. Stars held in their orbits stay held. The atoms in your body remain exactly as they are, exactly where they belong. The expansion only wins out across the truly vast and empty gulfs between distant galaxies, where there is too little matter and too little gravity to resist it. Here, at home, we are an island of stillness and safety, held firmly and lovingly together, while only the great empty oceans far beyond us slowly widen. The stretching of the universe cannot touch you. You are held, you are gathered, you are safe. And now we come to the very edge of what we know, the possible eighth layer, the faintest and most uncertain motion of all, and the one that some of the most careful minds in the world are still quietly puzzling over tonight, even as you drift. Remember that ancient light, the afterglow of the Big Bang, the still backdrop against which we measured our great 1.3 million mile an hour drift. From the way that light looks ever so slightly warmer in one direction and cooler in the other, we can read off our own motion through the cosmos, and it comes to a little under 370 kilometers every second, aimed toward a particular point in the sky. That is our speed through the universe, as told by the oldest light there is. Now, here is a beautiful test that two astronomers, George Ellis and John Baldwin, proposed back in the year 1984. If our motion is simply our own speed through an otherwise smooth and evenly filled universe, then it should leave behind a second fingerprint, somewhere else entirely. The most distant objects we can see, the brilliant blazing cores of far-off galaxies that we call quasars, should appear ever so slightly bunched up in the direction we are heading. By a precise amount, we can calculate in advance the same direction the ancient light points us, and just as importantly, the very same size. So astronomers went and checked. They mapped well over 1 million distant quasars, scattered all across the whole sky, and they measured how those quasars leaned, and the direction matched beautifully, pointing just where it should, in fine agreement with our motion through the ancient light. But the size did not match. The lean in the distant quasars came out about twice as large as our motion alone should produce, twice as much as it ought to be. It is a small discrepancy in one sense, and an enormous one in another, large enough that it should arise purely by chance only about once in many millions of tries. And other teams, using different methods and different mathematics, went back and checked the work, and kept finding the very same puzzling excess. The distant universe leans more than our speed can explain, and no one yet knows why. So let us sit gently with the possibilities, for there is no need at all to resolve them tonight. Perhaps we are simply moving faster through the cosmos than the ancient light suggests, carried by some motion we have not yet fully accounted for, a deeper current beneath all the others. Or perhaps, and this is the stranger and more wondrous thought, the distant matter of the universe is genuinely a little lopsided leaning faintly toward one direction, hinting that the cosmos itself has some preferred way of facing after all, that it is not perfectly the same in every direction as we have long assumed. Or perhaps, and this too is entirely possible, it is a subtle trick of measurement, some quiet bias hidden in the way we survey so many faint and distant objects across the sky, a bias that, once understood, will make the whole puzzle gently dissolve into nothing. Careful and honest scientists are arguing for each of these in good faith this very year, and the only honest answer, the one worth carrying down into sleep, is that we do not yet know. It is a true and living question, sitting open at the far edge of everything we have mapped. What we do know is that the question will not stay open forever. A new generation of great observatories is opening its eyes even as we speak. The Vera Rubin Observatory, with its enormous camera, beginning to map the entire southern sky again and again. The Euclid Space Telescope, charting the shapes of billions of distant galaxies, and the vast square-kilometer array, listening for the faint radio whisper of the deep universe. Between them, they will measure this faint cosmic lean with such precision that the mystery will finally have to give up its answer. Within our own lifetimes, in all likelihood, we will know whether the universe truly drifts towards some hidden direction, carrying a preference written into its very structure, or whether the anomaly fades quietly away beneath sharper and steadier eyes. And so we are left, tonight, in the most peaceful place that science ever truly offers. Not at a tidy answer, but inside a living, breathing question. We may be drifting toward a horizon the cosmos secretly favors, carried along by a current deeper and stranger than all the others, one we are only just beginning to learn how to sense. Or we may not be. Either way, the drift, if it is real at all, is so unimaginably gentle and so vast that it asks absolutely nothing of you. You do not need to know how it ends. You do not need to solve it, or settle it, or hold it in your mind. You are allowed tonight to simply rest here in the soft uncertainty, carried by whatever quiet currents move beneath us all, while the most patient and careful minds of our age keep their long watch on the far edge of the dark so that you do not have to. So let your thoughts grow soft and slow now, here at the far frontier of everything we know. We have come such a long way tonight, all the way from the gentle turning of the ground beneath your bed to the faint and uncertain lean of the most distant light in all the universe. And through every single step of it, you have done nothing at all but rest. That is the quiet lesson folded into all of this. You do not have to chase the answers. You do not have to hold the whole vast picture in your mind at once, or keep any of it from slipping away. The universe will go on falling and flowing and stretching and gently leaning, whether you watch over it or not, whether you understand it or not, carrying you tenderly along through every bit of it. And tonight, the only thing being asked of you is to let go and to be carried and to sleep. And so we come gently back, slowly, softly, the way you would carry a sleeping child in from the car. We begin the long, quiet journey home through all the layers we have traveled tonight. We come back from the faint and uncertain lean of the most distant quasars, that whisper of a possible eighth current at the very edge of the knowable. Back from the great slopes of Laniakea, where 100,000 galaxies slide like streams of light toward a hidden basin. Back past the bright smudge of Andromeda, falling toward us across 2.5 million years of darkness. Back in through the soft, glowing bubble of our own heliosphere, past the gentle bow wave at its prow. Back into the slow, turning carousel of the Milky Way, past the quiet black hole at its calm and distant heart, back to our own warm sun, one ember among the hundreds of billions, back down onto this small blue world, turning faithfully on its axis, all the way home, to this room, to this bed, to the quiet rise and fall of your own breathing in the dark. We have traveled so far together tonight, through every layer of our great cosmic fall, the one we called We're Falling Through Space at 1.3 million MPH. And here is the truth we found waiting for us at the bottom of it all, the one worth carrying down into sleep. Stillness was never really the absence of motion. It was something far kinder than that. You feel still tonight, not because nothing is moving, but because everything is moving together, smoothly and faithfully, all of it carrying you at once, so perfectly matched and so gentle that the enormous speed simply disappears, and all that remains is rest, the spin of the earth, and its fall around the sun, and the sun's long arc around the galaxy, and the galaxy's drift through the dark, and the slow slide of everything down the valleys of Laniakea. Every one of those motions holds you just as tenderly as the bed beneath you. You are not a bystander, watching the universe move past your window. You are a living, knowing part of that movement, riding every one of its currents at once, held safe and warm at the calm center of an unimaginable motion. There is a kind of peace in that I hope you can feel as you drift off. You do not have to do anything to take part in the life of the cosmos. You already are part of it, woven all the way through it, carried by it from the moment you were born and held by it still, this very night. The same gravity that shapes the orbits of galaxies is the gentle weight that holds you in your bed. The same long fall that began before the earth had cooled is the one that rocks you softly toward sleep right now. Thank you for spending this part of your night drifting through the cosmos here with me. If these slow journeys bring you some measure of peace, a quiet subscription helps us keep mapping the dark together on the clear night still to come. But there is nothing left for you to do now. Nothing to follow, nothing to remember, nothing to hold on to. You can let all of it go. Let the spinning earth carry you the way it always has and always will. Let it turn beneath you and circle the sun and sweep around the galaxy and fall down the long slopes of Laniakea, all of it at once, all of it gentle, all of it carrying you softly onward through the dark as you drift the rest of the way into sleep. You are exactly where you belong. You are perfectly safe, and you are already moving smoothly and silently and beautifully toward the morning. Rest now. Good night.